Have you ever wondered why a cup of hot chocolate feels warm to your touch, or why an ice cube feels cold? It's a question that might sound simple, but the answer takes us on a fascinating journey into the world of heat and temperature. Heat, my friends, is more than just a sensation. It's a form of energy. Picture this. When you heat up a pot of water, you're actually transferring energy from the stove's burner to the water. This energy causes the water molecules to move faster and faster, which in turn heats up the water. This is the essence of heat, a form of energy that can be transferred from one object to another. But what about temperature? Is it the same as heat? Not quite. Temperature is the measure of the average kinetic energy of the particles in an object. The more kinetic energy these particles have, the higher the temperature of the object. So, when you touch that cup of hot chocolate, what you're actually sensing is the high kinetic energy of its particles. Now let's talk about our icy friend, the ice cube. When you touch it, you feel a cold sensation. This is because the ice cube has a lower temperature than your hand. Therefore, heat energy from your warm skin is transferred to the ice cube in an attempt to achieve equilibrium. The loss of heat energy from your skin to the ice cube is what gives you that chilly feeling. So you see, heat and temperature are intrinsically linked, but they are not the same. One is a form of energy that can move from one place to another, and the other is a measurement of how much kinetic energy the particles in a substance have. So in essence, when you feel something is hot, you're actually feeling the transfer of heat energy from the object to your skin. And when you feel something is cold, it's because heat energy is being transferred from your skin to the object. It's a fascinating dance of energy, wouldn't you agree? Now that we know what heat and temperature are, how do we measure them? A great question indeed. Our most trusted ally in this endeavor is the humble thermometer. A thermometer is like the interpreter between us and the world of heat. It translates the language of temperature into something we can understand. But how does it do that? It's all about the magic of expansion and contraction. Inside a thermometer, you'll find a liquid, typically mercury or alcohol. When this liquid is heated, it expands. When it's cooled, it contracts. This movement is what enables a thermometer to measure temperature. The liquid inside the bulb of a thermometer expands when it's hot and rises up the narrow tube, or contracts when it's cold and descends. The scale on the thermometer, you see, is calibrated to match this movement. Each marking on the scale corresponds to a specific temperature, giving us a precise measurement. But why mercury or alcohol? Well, these liquids are chosen for their predictable and consistent behavior. Mercury, for instance, expands and contracts at a steady rate with changes in temperature, making it reliable for accurate readings. Alcohol, on the other hand, is used because it remains liquid at temperatures where mercury would freeze, making it useful in colder climates. Now let's talk about the laboratory thermometer. It's a more precise instrument used in scientific experiments. It has a longer, narrower tube than a standard thermometer and a smaller bulb, which allows for more accurate readings. It's calibrated in much smaller temperature increments, allowing scientists to measure temperature changes down to a fraction of a degree. So, a thermometer allows us to quantify temperature, giving us a clear and precise measurement of how hot or cold something is. It's our key to unlocking the mysteries of heat and temperature, a tool that allows us to explore this fascinating world in a meaningful and measurable way. Heat doesn't just stay in one place, does it? It moves from one object to another, but how? Let's dive into the intriguing world of heat transfer. There are three primary methods that heat uses to travel: conduction, convection, and radiation. Imagine you're cooking on a stove. The burner is hot, and it heats up the bottom of your pot. This is an example of conduction, where heat is directly transferred from one object to another through physical contact. The particles in the hot burner vibrate vigorously, and these vibrations are passed on to the cooler particles in the pot, heating them up. Now, picture a pot of water boiling on that same stove. The heat from the burner warms up the water at the bottom of the pot. This warm water rises to the top, while the cooler water at the top sinks to the bottom to be heated. This cycle is called convection, and it's the way heat circulates through liquids and gases. The third method is radiation. This one's a bit different as it doesn't require a medium like a solid, liquid, or gas to travel through. Think about the warmth you feel when you step out into the sun. There's no physical contact between you and the sun, and yet you can feel its warmth. This is because heat is being radiated or sent out in waves from the sun, and these waves are absorbed by your skin, making you feel warm. Now, these methods of heat transfer aren't exclusive. They often work together. For instance, when you're cooking that pot of soup, conduction is heating the pot from the stove. Convection is moving the heat through the soup, and radiation is releasing some of the heat into the surrounding air. Heat transfer is happening all around us, all the time. It's a fundamental process that powers our world. So, the next time you feel the warmth of a hot cup of tea or the chill of a cold breeze, remember the amazing journey that heat has taken to reach you. Why do we wear different types of clothes in summer and winter? It's an interesting question, isn't it? The answer lies in the fascinating world of thermal properties of materials. You see, different materials interact with heat in unique ways, and our clothing choices are often a strategic response to this. Let's start with summer. The sun's rays beat down and the temperature rises. It can get quite hot, and our bodies naturally generate heat as well. To keep our body temperature in check, we need to shed this excess heat. That's where light, breathable materials come in. Fabrics like cotton and linen are perfect for summer. They are woven in a way that allows the heat to escape from our bodies and the fresh air to come in. It's like having your own personal ventilation system. Now, when winter rolls around, the game changes entirely. The temperature drops, and suddenly keeping warm becomes the priority. But how do we do that? It's all about insulation. Thick materials like wool and down are great insulators. They trap the heat generated by our bodies and create a cozy envelope of warmth around us. The tiny air pockets within these materials act as barriers that slow down the transfer of heat, keeping us snug and warm even in the biting cold. But it's not just about the type of material. The color of our clothes can also play a part in how we experience temperature. Dark colors absorb more heat, so they can help us feel warmer in winter. Light colors, on the other hand, reflect heat, making them a cool choice for summer. So you see, the clothes we wear are more than just fashion statements. They are our personal thermostat, helping us adapt to the changing temperatures around us. The right clothing can make a world of difference in how comfortable we feel in any given season. So the clothes you wear can greatly affect your comfort level by controlling the amount of heat that is transferred to or from your body. We've learned a lot today about heat and temperature, haven't we? We've journeyed through the intriguing world of heat, where we revealed that heat is a form of energy that flows from a hotter object to a cooler one, and temperature is a measure of that heat energy. We've also discovered that temperature isn't just a number on a thermometer, but a fascinating indication of the kinetic energy of the particles in a substance. In our exploration of measuring temperature, we discovered the magic of the laboratory thermometer. This humble instrument, often overlooked, is a scientific marvel, enabling us to determine the exact degree of heat present in a substance. It's not just a tool for scientists. It's a tool for life, helping us cook our food to perfection, control our home environment, and even diagnose illness. Then, we delved into the science of heat transfer, a process that affects every aspect of our lives. We learned about conduction, where heat travels through a solid, convection, where it moves through liquids and gases, and radiation, where it travels in straight lines. We also learned that heat transfer isn't just about warming our homes or cooking our food, but it's also how our Earth stays warm, courtesy of the sun. Lastly, we explored why we dress differently in winter and summer. We learned that the clothes we wear are more than just fashion statements. They're practical tools that help us control our body temperature. In summer, we opt for light, breathable fabrics that allow heat to escape, while in winter, we choose thick, insulating materials that trap heat and keep us warm. Understanding heat and temperature not only helps us make sense of the world around us, but also allows us to make smart decisions that affect our comfort and well-being. So the next time you sip a hot chocolate or put on a warm sweater, you'll know a little more about the science behind it.